All right. So what I've given, hi guys, excuse me. We have a lot to get through, so I want to make sure that we have time. Okay, so I've given you the coast table there. So that shouldn't be too much of a surprise. At 0, we're at a maximum at 1. Pi over 2, we're at 0. Pi, we're at -1. 3 pi over 2, we're at 0 again. And 2 pi, we're back to 1. And then if we did it in the negative order, it would work as well. So now cosecant, we're going to do the same thing that we did with the cosecant chart. We're going to do with the same thing we're going to do with the secant. We're going to reciprocate all of our y values. So the reciprocal of 1 should be 1. What's the reciprocal of 0? Undefined. You guys sound so excited. So undefined is going to result in an asymptote. -1. Undefined. 1. Undefined. -1. Undefined. +1. Okay. It follows the exact same pattern. The nice thing about cos graphs and sine graphs and cosecant graphs and secant graphs is they kind of follow the same sort of patterns. So that's pi. It's 2 pi. -pi. All right, and then I just need a 1 and a -1. Are you guys okay if I put my asymptotes on first? Just because I have my ruler out. I love it. I love your flexibility. I appreciate that. Okay, so my first asymptote in the positive is at pi over 2. And again, asymptotes have to go on with dashed lines to indicate that they're not part of the function. They're just a boundary. And then I have another one at okay, my asymptotes are all different lengths. That's awesome. Sort of the same length now. All right. So at 0, what value am I? 1. Beautiful. Maybe I'll use that one. I'll use a green. So I'm here at a maximum. So same sort of thing. It's going to result in that parabola. So which way is the parabola opening? Up or down? Am I at a max or a min? A max. So I'm opening up. Right. Okay. If I'm at pi, I'm now at -1. Which way is my graph going? Down. It's the other option. Okay, if I'm at 2 pi, I'm back to 1. And we did the values on the cosecant chart. If you want me to do them again to prove to you that it's both up and down, I can. If you would like that, that's not a problem. All right, that's exciting. Okay, so do you need a second to get that copied down? Okay. Are we good? Perfect. Okay. All right. Let's fill out some stuff about it. Amplitude? No, because it doesn't follow a wave. So we're going to say that there's none. What's the period of this one? So remember that we're looking for where the pattern repeats, right? 2 pi. Domain? Right. Okay, so we're going to do our general statement. So we can go negative infinity to positive infinity, but we have to exclude those asymptotes. If you want to put XER, that's fine. So theta cannot equal. Where's my first positive asymptote? I believe these were all thetas. Like theta, you can see I put x's there, but I changed them to thetas. So we're going to use, like if it's defined as theta, we're going to use theta as our value. And I do switch back and forth between them. And then we're just going to make a general solution for that. We're going to add a period, right? No. When's our next asymptote? So our next asymptote is 3 pi over 2. So what's the distance between here and here? Pi. Okay, so we are going to add plus pi k, where k is an element of the integers. Because it was my very first positive asymptote. In sine, our first one is on the y-axis, so it's 0. Okay. Range? Another weird one, right? So we're going to go to and negative 1 is included, and then positive 1 to positive infinity in unison. I need you guys to come talk to my grade 10s and tell them that they need to at least know what set notation means to read it. They don't think they have to learn it.
I still don't know what set notation.
Oh, don't say that. Basil, you are not invited to the conversation then. Zeros of the function. None. Y-intercept. 1. Asymptotes. Remember that you just did that statement here. What's the only thing that changes?
It's an equal.
That equal sign, yeah. Okay, for the record, you guys hated this 2 days ago, and today you're just perfectly fine doing this.
My spirit's just been broken down.
Oh, okay, so I've broken you. Good to know. Good to know. It's just, you're just sad now. Ouch, I've just broken your spirit. Okay. Oh, the big tan chart again. Okay, let's do our positive stuff first. At 0, what's tan at 0? We're just, okay, so unit circle. You're at 0. This point is 1, 0. How do I find tan? So tan is tan theta is equal to sine theta divided by cos theta.
No, 0.
Okay, everybody good with that? Okay, you need to know how to calculate it if you can't memorize it. Like, that's the most important thing. It's okay if you don't memorize it. I'm not great at memorizing, but you need to know how to calculate it. Okay, so if we know that that is 0, what's pi over 4? 1. Pi over 2? Undefined. Once you get the pattern going, you catch it, right? And so pi is going to be 0. 5 pi over 4, 1. 3 pi over 2, undefined. 7 pi over 4, 2 pi. Okay, so then if we go up the chart, if I'm positive 1 here, I'm -1 there. And then undefined. And then what do I do? 1, 0, -1, undefined, 1, 0. And once you get it, like, it doesn't take long. Like, you follow the pattern. That's the great thing about this stuff. Okay, so now we have to reciprocate everything. So if it was 0 at 2 pi, what is it now? Undefined. And if it was 1, it's still 1. If it was undefined, it's 0 now. We're doing cotangent graphs. Yeah, sorry. I thought we already done the tangent graph, so, and this is the reciprocal functions. So if it's -1, it's still -1. 0 becomes undefined, 1 stays, undefined becomes 0, -1 stays, 0 becomes undefined, 1 is 1, 0, -1, oh, I'm off the chart, sorry, I'm just doing my table, I'm not even paying attention. Undefined, 1, 0, -1, undefined. The reason why we need way more points in the tangent graph is because of the ones. We need something else other than zeros and undefined. You wouldn't have enough to be able to do it. Oh, okay. Oh dear, those do not even look even. Ooh, that's bad, oh bad. Give me 2 seconds. No, they never look even. I gotta put 4 spaces in between there, so I'm gonna try to space it out a little more. Oh, wouldn't it though, Basil? Okay, we're just gonna take a minute. We're just gonna take a minute while that dries. Oh, that's bad, oh bad. That's not good. Now my pen's all gummed up. Oh, what have I done? I've made poor life decisions. Oh, still making poor life decisions. All right. When in joke, get the Sharpie marker. Are you guys throwing stuff at each other? Feel like it's out of control. Oh, that's even worse. I've made a poor life choice. Okay, I don't know. I tried. I went for the Sharpie marker. It was a bad decision. Okay, let's graph this, and let's do the positive because my negative's drying right now. Okay, shall we throw our undefineds on right away? Let's throw our undefineds on right away. So I have an undefined at 0. Basil, are you the one throwing stuff? I didn't really peg you as that kind of kid, but... Okay, and then 2 pi. And then again at pi and at 2 pi. Negative pi, and -2 pi. All right. Oh, it's terrible. Who picked this? Okay, it's a little bit better. That's a negative pi over 2, but I don't think I can fix it. It's as good as she's going to get. All right, let's graph this. I'm going to do my positive first just because I feel more comfortable there. At pi over 4, I am at, oh, I didn't do my increments here. Jeez Louise, I'm all over the place. I'm at 1. And then at pi over 2, I'm at 0. I started right there. I started the first positive one. I just figured I'd do my positive aside first. And then at 3 pi over 4, I'm at -1. So when I connect these again, they shouldn't be a straight line. It should be kind of that wave through the 0. So it looks super similar to a tan graph, but this time it's rising to the left and falling to the right, which is opposite to what we did, and there is a shift as well. Because I had 0, 0, 0 was a point on my last graph. Okay? So if you know this pattern, I don't even have to look at my table of values. Yeah.
I'm having a stroke. It says 3 pi over 2 on the graph, but 3 pi over 4 on the...
What? But this is 3 pi, oh, sorry, I'm moving around. That's 3 pi over 4.
Oh, yeah, okay.
And it's at -1,
Okay.
which that says.
How do you draw them again? How do you draw them? Those lines?
You just did it.
I just did it. Looks like that. It's not great, but I did it. It's okay. No judgment. Look at my negative pi over 2. Like, I'm not one to talk. Plot your points. So I'm going to show you, I think I have it in this one. I might print it off for you guys, that I have all 6 tan graphs on one sheet of paper, so that you can see the basic graph together. I think that might be useful for you guys.
Are we going to get that on our graphic performance sheet?
No.
Wait, 6 tan graphs? What does that mean?
6 tan graphs.
Trig graphs, do you mean?
Oh, sorry, 6 trig graphs. That's, I apologize. I was like, there's 6. I don't know what else to say. 4 waves. Well, no. 2 waves. 2 weird parabolas. And then tangents. One goes this way, one goes that way. Okay, amplitude for the cotan graph. Amplitude, none. Period. So we're looking for where the pattern repeats. Pi. What's the domain? Oh, that should be theta. Theta ER, because I've done everything with thetas. And this one will be theta cannot equal. Where are my asymptotes? Where's my first asymptote? My first asymptote's at 0. So, and when does my next asymptote occur? Pi. And again, you might see it written like that, where it doesn't have the 0 in front. Yeah. Okay, what about the range? This one's easy.
Oh. Huh? Oh.
No, not this.
Right? The range YER is good. Right? Zeros of the function. We got lots. So we're going to make a general solution for it. When you have lots of them, you don't want to list them, because they could potentially go on forever. So what are my zeros? Where's my first 0 occur? Pi over 2. Plus every pi, yep. Pi k, where k is an element of the integers. Y-intercepts? None, because we have an asymptote there. And asymptotes, we already figured out. The only thing that changes is it's an equal sign now. Okay. I just want to show you that page and you guys can tell me if you think it would be helpful. I guess I could probably stop the video. That might be helpful.